Again, teacher Abby, and for today's video, we're going to talk about general term of a sequence. And for the objective of today's lesson, we need to find the general or end term of a sequence. By definition, general term is the formula that is used to calculate any term in a given sequence. This equation reveals the pattern in a given sequence. It's either recursive or explicit. To better understand how we formulate the general term, let's consider these conditions. These are two conditions in finding the general term of a sequence. Take note that this process applies only to sequences whose nature is linear or quadratic. Condition number 1. If the first difference is constant, use the equation a sub n is equal to d times n plus b in finding the general rule of the sequence. In sequence 3, 6, 9, 12, 15, we all know that the difference is equal to 3. Therefore, their difference is constant. Condition number 2. If the first difference is not constant and the second difference is constant, use the equation a sub n is equal to a times n squared plus b times n plus c. In the equation 2 times 8, rather 2, 8, 18, 32, we have a common difference of 6, 10, 14 respectively. So, the first difference is not constant. While, if we're going to get their difference again, we're going to have 4 in each, wherein their difference is constant. Let's have an example for condition number 1. For example number 1, find the general rule of the sequence 7, 9, 11, 13, and 15. First, we need to create a table of a sub n and n values. As you can see, these are the values of n, and below are the values of a sub n, or the given sequence. We all know that the first term will be your a sub 1, the second term will be a sub 2, the third term will be a sub 3, and so on and so forth. So the value of the sequence depends on its value of n. Now, let us take their difference. The difference between 9 and 7 is 2. 11 minus 9 is also 2. 13 minus 11 is also 2. And 15 minus 13 is also 2. So as you notice, we have a constant difference which is equal to 2. Therefore, the general rule of the given sequence is linear. In this case, we're going to choose a value from the table and find the value of b using a sub n is equal to d multiplied by n plus b, since the given sequence is linear. If we're going to choose n sub 1, it will have a term which is a sub 1 that is equal to 7. Then our common difference, which is d, is equal to 2. As we substitute the values, a sub n will be equal to 7, d, or the common difference, is equal to 2, then our n is equal to 1 plus b. So we need to look for the value of b. Simplifying 2 times 1, the answer will be 2. Then, to get the value of b, we need to isolate it in one side. So we need to transpose positive 2 in the other side. That will be negative 2. So it will be 7 minus 2 equal to b. And we all know that 7 minus 2 is equal to 5. And that's the value of our b. Now, let us substitute the values of d and b in a sub n is equal to d times n plus b to get our general rule. The value of our b again is 5 and our common difference d is 2. So if we substitute that 1, that will be 2n plus 5. Now, let us try to check whether our general rule is valid or correct. So if we substitute this 1 on any values on the table, for example, we choose n is 5 and our a sub n is equal to 15. If we substitute, a sub n is 15 is equal to 2 times our n, which is 5 plus 5. So that will be 2 times 5 will be equal to 10 plus 5. Then we all know that 10 plus 5 is equal to 15. And 15 is equal to 15. Therefore, our general rule is correct. In our example number 2, find the general rule of the sequence 10, 7, 4, 1, and negative 2. First, we need to create a table of a sub n and n values. At the top are the values of n, and at the bottom are the values of a sub n. Always remember that the first term of a sequence will be a sub 1 corresponding of the n values equal to 1. The second term will be a sub 2. The third term will be a sub 3, and so on and so forth. Now, let us take their difference. 7 minus 10 will be equal to negative 3. 4 minus 7 is equal to negative 3 also. 1 minus 4 is also negative 3. And negative 2 subtracted by 1 is also negative 3. Take note that if you're going to get their difference, you must use the current term subtracted by the previous term. So as you notice, we have a common difference which is negative 3. Therefore, the general rule again in this given sequence is linear. Now, let us choose a value from the table and find the value of b using a sub n is equal to d times n plus b. Now, assuming that we pick n is equal to 1 and the first term, which is 10, will be our a sub n, our D is equal to -3. Substituting the values, we able to get 10 equal to -3 times 1 plus B. Simplifying -3 times 1, that will be equal to -3. And we need to get the value of B, so we need to isolate it on one side. Therefore, we need to transpose -3 to the other side with 10, making -3 as +3. So that will be 10 plus 3 equal to B. And we all know that 10 plus 3 is equal to 13. So that will be the value of our B. Next, we need to substitute the values of D and B in A sub n is equal to D times n plus B to get the general rule. Assumingly, the values of B is equal to 13 and our common difference D is equal to -3. So we able to get A sub n is equal to -3 n plus 13. So that will be our general rule as we substitute the values of B and D on our formula. Now, let us check whether our general rule is correct. If we pick the third term, 4, and having a value of n which is 3, substituting that one on the formula of general rule, our A sub n will be 4, and the value of n will be equal to -3. So as you notice, -3 times 3 will be equal to 9. Or -9 rather. Now, -9 plus 13 will be equal to +4. And 4 is equal to 4. Therefore, our general rule is correct. Since we're done with examples on condition 1, now we move on to the examples of condition 2. For our example, for condition number 2, we need to find the general rule of the sequence 2, 3, 5, 8, and 12. Now, let us create a table of A sub n and n values. As you notice, the values of n at top corresponds to the values of A sub n or the terms of the sequence. Remember that the first term is A sub 1 and the second term will be A sub 2. The third term will be A sub 3 and so on and so forth. Now, let us take the difference of A sub n. If the first difference is not constant, let us take the second. In this case, we need to subtract the current term by the previous term. So 3 minus 2, that will be 1. 5 minus 3 is equal to 2. 8 minus 5 is equal to 3. 12 minus 8 is equal to 4. As you notice, their constant is not their difference is not constant. Now, let us try to get the difference into a second level. 2 minus 1, that will be equal to 1. 3 minus 2 is equal to 1 also. 4 minus 3 is also equal to 1. So, as you notice, the second difference is equal to 1. Therefore, the general rule of the given sequence is quadratic. And now, let us pick 3 sets of values from the table and form 3 equations. We also need to remember that we're going to use the general equation for quadratic, which is a times n squared plus b times n plus c is equal to a sub n. Let us solve for equation number 1. If we chose n is equal to 1, the value of our a sub n will be equal to 2, or the first term. As we substitute the values to the general equation, we're going to have a times 1 squared plus b times 1 plus c is equal to 2. Simplifying 1 squared, that will be equal to 1. And we all know that b times 1, any number multiplied by 1 is itself. So that will be equal to b. So leaving behind a times 1 plus b plus c equal to 2. And again, any number multiplied by 1 is the number or the variable itself. So that will be a. So the equation 1 will be a plus b plus c equal to 2. Now, let us try to get the equation number 2. In equation number 2, I'm going to choose n is equal to 2, so I will be able to get the value of a sub 2 or the second term, which is equal to 3. And again, let us substitute to the general equation. We're going to have a times 2 squared plus b times 2 plus c is equal to 3. Simplifying 2 raised to 2, that will be 4. And b times 2 will be 2b. Multiplying a times 4, that will be 4a plus 2b plus c is equal to 3. So that will be the value or the equation number 2. For equation number 3, we're going to choose the value of n, which is equal to 3, and we're going to have the a sub 3 or the third term, which is equal to 5. Again, let us substitute to the general equation. We're going to have a times 3 raised to 2 plus b times 3 plus c is equal to 5. Simplifying 3 raised to 2, that will be equal to 9. And b times 3, that will be equal to 3b. And the rest of the terms will be copied. Now, we can simplify a times 9. It will become 9 times a, and the rest of the terms will be copied. So the final equation or the equation number 3 will be 9 times a or 9a plus 3b plus c equal to 5. And now, let us manipulate the equations we got a while ago. Let us solve using systems of linear equation. Let us try to solve using elimination method. If we chose equation 1, which is 4a plus 2b plus c equal to 3, and equation 1, which is a plus b plus c is equal to 2, if we're going to eliminate that one, 4a minus a will be equal to 3a, 2b minus b, that will be b, and c minus c will be cancelled out, and 3 minus 2 is equal to 1. So 3a plus b is equal to 1 will be our equation number 4. Since we do not arrive on any values of any variable, we can still use elimination method. If we're going to try equation number 3, 9a plus 3b plus c equal to 5, and equation number 1, a plus b plus c is equal to 2, and we all know that 9a minus a will be equal to 8a, 3b minus b will be equal to 2b, and c minus c is again cancelled out. 5 minus 2 is equal to 3. So this is our equation number 5. Now let us try to use equation number 4 and 5. So in order for me to get values or cancel out variables in these equations 4 and 5, I need to multiply 2 on equation number 4. Multiplying 2 on both sides in equation number 4, that will be 2 times 3a, that will be 6a. And 2 times b, that will be 2b. 2 times 1, that will be equal to 2. Then, let us copy the equation number 5. If we simplify 6a minus 8a, that will be negative 2a, and 2b minus 2b will be cancelled out, and 2 minus 3 will be equal to negative 1. So as you can see, we have a chance to eliminate the variable b. So now we can use negative 2a to get the value of a. So, to isolate a, we just need to divide both sides by negative 2. And negative 2 will be cancelled out. And negative 1 divided by negative 2 will be equal to positive 1/2. So, the value of a will be 1 over 2 or 1/2. Now, let us substitute the value of a is equal to 1/2 in either equation number 4 or 5. Now, I'm going to choose equation number 4. Our equation number 4 is 3a plus b equal to 1. Substituting the value of a, which is 1/2, that will be 3 1/2 plus b is equal to 1. Multiplying 3 on 1/2, that will be 3 over 2 plus b equal to 1. In this case, we can isolate b so we can get its value. Transposing positive 3 over 2 to the other side, that will be 1 minus 3 over 2 or negative 3 over 2 plus 1. And simplifying that 1, the value of b will be equal to negative 1/2. As you can see, we have able to get the values of a and b. Now, from the original equation, let us substitute the values of a, which is 1/2, and values of b, which is negative 1/2, in either equation 1 or 2. In this case, I'm going to choose equation number 1. And equation number 1 is a plus b plus c is equal to 2. Substituting the values of a and b, that will be 1/2 minus 1/2 plus c is equal to 2. And there's a chance to get the value of c. Transposing or simplifying 1/2 minus 1/2, that will be equal to c is equal to 2. So there, we're able to get the values of a, b, and c. Since we already have the values of A, B, and C, let us substitute the values of A is equal to 1/2, B is equal to -1/2, and C is equal to 2 in the general equation. Remember, the general equation for quadratic is A times n squared plus B times n plus C is equal to A sub n. Substituting them, the values of A, B, and C, that will be 1/2 times n raised to 2 minus 1/2 times n plus 2 equal to A sub n. And simplifying that one, or rearranging it, it will be A sub n is equal to 1/2 n raised to 2 minus 1/2 n plus 2. So the final answer will be A sub n is equal to 1/2 times n squared minus n plus 4. By getting the GCF of this equation, which is 1/2. Now let us try to check whether the given general rule or nth term is valid or correct. As you remember, these are the table of n values and A sub n values a while ago. So, if we're going to choose n equal to 1 and A sub n equal to 2, substituting the values of n in the general equation, that will be 1/2 is equal to 1 raised to 2 minus 1 plus 4. And we all know that simplifying this one will give you the value of 2, which is our first term. And now, if we try to get the value of n, which is equal to 2, substituting that one to the general equation or the general rule we've got a while ago, that will be 1/2 times 2 raised to 2 minus 2 plus 4. And simplifying this one, the value of this will be equal to 3. And that is our second term. If we substitute the values of n, 3, 4, 5, we're going to get the values of 5, 8, and 12. So, therefore, this general rule, A sub n is equal to 1/2 times n raised to 2 minus n plus 4 is correct. Since we're done with our examples, we're going to have a simple activity. In this activity, you're going to find the general or nth term of the following sequences. Number 1, 12, 9, 6, and 3. Number 2, 2, 6, 10, 14. Number 3, -5, -2, 1, and 4. And now, that's the end of our lesson. Thank you for watching, and I hope you have learned something. If you have questions, you can message me via Facebook Messenger, Abby Mendoza. Again, thank you for watching!